So the second part of our so-called deliverables is about targeting leukemia. And one of the ways of targeting it that has come out of the CIRM project is a treatment called Cirmtuzumab. And believe me, I practice saying that over and over in the mirror. Cirmtuzumab, so I hope I got it right. And the woman who's here to tell you about that is Dr. Catriona Jamieson. When you say the phrase cancers of the blood, just the sound of it can chill the blood. And she knows this very well because she's been hands-on with patients with hematologic malignancies. And now, as the director of stem cell research at the Moores UCSD Cancer Center, she looks for new kinds of therapies that can make life better for the patients who so profoundly need those treatments. Come on up.
Thank you very much. It's really a pleasure to be here on behalf of our CIRM Alpha Stem Cell Clinic and Cirmtuzumab team at UC San Diego. I took a little longer in clinic yesterday when I received my patients because now we have the problem with sustainability of the promise of stem cell research. Now, thanks to Bob Klein having the prescient notion that stem cell research would matter clinically and championing the cause of having funding specifically dedicated to this, we have patients who have actually had responses. And now they want to know how long will this response last. As Bob knows very well, we were among the first to have cancer stem cell funding from CIRM and worked with a local company to develop a novel JAK2 inhibitor, as it's called. And so one of the first patients on that trial who was told that she should get her affairs in order and actually not consider any further therapy because her disease was too advanced, had a spectacular response to a JAK2 inhibitor and met her high school sweetheart again. And she and Dave had a very good time for 8 years until that single JAK2 inhibitor stopped working. And when I was at her funeral last year at this time, the last thing they said, her fiance said, Dave, was he wanted to thank CIRM and Bob Klein for the championship of the cause of developing novel therapies for patients. She had an extra 8 years, so they were grateful for that. I wished, of course, it would have been longer. I miss Teresa. I miss her compassion and her clarity and her drive to make things better for other people. So I think she laid down the gauntlet for people that have malignancies, some of them rare. I think in leukemia we've seen tremendous advances because of talent, tenacity, and teamwork. Often when we want to tell a scientific story, we hear it's about one person. One person made that discovery. They should get the Nobel Prize. What you don't hear about is the team. And so it's really a privilege to be able to talk about the talent, tenacity, and teamwork that went into making a humanized monoclonal antibody targeting the cancer stem cell antigen called ROR1. This was really pioneered by Tom Kipps, who's in the audience. And I would really like our team to stand up. We've got our entire Alpha Stem Cell Clinic team here. Come on, you guys. Tom, Mike, Riley, here's the team. Tom's at the back there. Yeah. So this is about sharing. This is about sharing scientific curiosity, sharing the compassion to deal with patients and their families, and sharing, hopefully, about the Alpha Clinic Network sites. As a result of our IRB Reliance Agreement that was really championed by Steve Peckman and the UCLA team, and it actually allows us to open trials once it's approved at one IRB site at all the sites. So this is something Maria Milan really pushed for. John Adams, John Zaya, thank you so much. Jeff Lomax has really helped us guide patient education as well. But anyway, so I have a unique perspective from my office. I think we can take chances because I watch people jump off a cliff with a parachute. And they seem to think it's okay. So I think we can take some chances to help patients. But these have to be really plausible approaches. We can't give people false hope. I don't think hope is enough. I don't think unbridled hope is enough. I think you need to have the appropriate backup plan and strategy to develop these therapies. So we have an alpha clinic where we're really fortunate to have Betty Cabrera as our project manager, but also we have a number of trial experts so that we don't just keep drinking our own Kool-Aid and thinking this is the best thing that came along. They actually give us more information about the specific diseases, again with Tom Kipps guiding us on hematologic malignancies and Ted Ball on stem cell related therapies. Now I'm starting with the acknowledgments, as you can see, because I think that's the most important part of giving a talk. This is all about collaboration, and now I'm really excited that the Alpha Clinic networks are working together, and we'll have an opportunity to make these trials more accessible to patients. I don't see the word patient as a stigma. We're all going to be patients. We're all going to require health care. But let's hope it's coordinated care and that we're not bankrupted by trying to coordinate that care, and that's where collaboration comes in again. So we have the capacity to work among the stem cell clinic networks to talk about potentially curative strategies. Now, a number of years ago, we started working on cancer stem cells, and these are the cells that lie dormant within a cancer and are able to wake up and clone themselves, or in other words, self-renew. These therapies tend to be impervious to therapies that target dividing cells like chemotherapy and radiation, and it's what most of my patients in clinic yesterday were scared of. They said, well, you know, doc, I thought I was going to be okay, and I feel kind of okay on this therapy you're giving me, but actually I'm really worried about relapse or progression. Can you tell me if I'm going to progress? Can you tell me if I'm going to progress to acute leukemia? And we're still at the stage where we're trying to understand what are the events involved in leukemia initiation versus progression to a more advanced disease. And that capacity to look at stem cells and the pathways to aging and cancer has really been bolstered by CIRM investment in discovery and sustainable investment in scientific discovery, so we can focus on intellectual curiosity and keep our teams together as a SWAT team so we can work on some more difficult problems. So as you know, hematopoietic stem cells have the capacity to self-renew, but what happens with cancers of the blood is they pick up mutations that allow them to survive for a long period of time, to evade innate and adaptive immune responses, and then they give rise to an expanded progenitor pool that then gains the capacity to self-renew. And it's that unregulated, unbridled self-renewal capacity that makes a cancer extremely malignant and resistant to disease. And that's why I'm so glad to talk to you today about the activation of the Wnt signaling pathway through the receptor for Wnt5A called ROR1 that we've been able to block thanks to the pioneering efforts of Tom Kipps and our CIRM team, thinking that maybe we can actually do this together. So as I was mentioning, Tom and his lab looked at ROR1 expression in a number of tumors, found it was highly expressed in these common malignancies, and particularly when they decided to invade and metastasize. So ROR1 expression had a lot to do with actually invasion and metastasis, and therefore relapse potential. So people that have a high ROR1 expression tend to relapse and have a shorter survival time. So we wondered, is this a cancer stem cell marker? So the thing about cancer stem cells is they respond to their environment. They're tricky. They respond to the environment, they get into a nice home where they metastasize to, and they go to sleep. They're resistant to apoptosis, or in other words, they have enhanced survival potential, and this is where ROR1 comes in. They have enhanced self-renewal, and they can actually remodel the niche of their home. So very malignant cells. When we got our CIRM Halt Leukemia grant, we were absolutely thrilled. This was a highly active anti-leukemia stem cell therapy grant, but we thought we may also be targeting cancer stem cells in a number of malignancies, not just leukemias, if this were to be successful. So we have the thought that ROR1 may be expressed by cancer stem cells in other aggressive malignancies like ovarian cancer. And more recently, the group of Ron DePino showed that there was epigenetic activation of the ROR1 ligand called Wnt5A in glioblastoma stem cell differentiation. and invasive growth. So we think that this is going to be a more common pathway used by cancer stem cells to survive and clone themselves. So ROR1 is an embryonic antigen. It's usually expressed during embryonic differentiation along the neuronal lineage. We found with our CIRM halt leukemia team that it was not expressed by normal adult tissues. And within 4 years, we were able to make a humanized antibody because CIRM gave us the appropriate guidance to focus on this, to focus on Tom's project as the most novel, most innovative, and potentially clinically impactful product to come of this rather large networked grant. So what we found is that UC961, as we originally called it, is actually capable of clearing chronic lymphocytic leukemia in immunocompromised mice, as seen here, in a dose-dependent manner. So that corresponded with plasma levels of the antibody. And interestingly, if you used it in combination in this humanized mouse model with what has become the standard of care for CLL, it worked even better, and that's ibrutinib. So we thought, well, where do you go from here? Where we went from there was to have a call with the FDA. We'd taken 4 years to develop this antibody, and the FDA said, well, you know, it's not expressed in mice. How do you even model if it's going to be toxic? So why don't you start at a really low dose? And we said, okay, we're willing to do that with the proviso that patients who start in the lowest dose cohort can actually come back and get the drug again or the antibody again in the extension phase. And that's essentially what happened. So this was our first alpha stem cell clinic trial. We've almost completed the trial. We've got Michael Choi as the champion PI. We've got Riley Kidwell working very closely with him. And basically, we've got up to the 20 milligram per kilogram dose, 24 patients treated. It's one of the highest accruing trials in the Alpha Clinic network. Patients want therapy that will prolong their treatment-free remission. They don't want to be nickeled and dimed by therapies that partly work. They want to eradicate their disease. And that's something we're striving to do with our team. I keep mentioning Tom because he's forever hopeful. As you can see, there he is holding the syringe from the first patient. We couldn't quite believe that day. So that was September 2014, so we've come a little way since then. And I think what we would really like to do is combine standard of care with Cirmtuzumab to really eradicate the cancer stem cells so patients in our clinics don't have to worry about relapse. They don't have to worry about Damocles sword hanging over their heads. Their cancer will degenerate, and hopefully they'll have a remission that's sustained, and they can move on with their normal lives. So that's what I'd like to say. I think what you'll hear from our Alpha Clinic team working on Cirmtuzumab is we're partway there. You know, we're very excited about the trial so far. We've got a partner, as Randy Mills explained, which is extremely important. We're moving into prime time, thanks to Jim Breyer with Octernal. And so I'm very pleased to let Jim take the podium.